Lesson 5-6, graphing inequalities with two variables. Essential question, how do you graph a linear inequality on a coordinate plane? The vocab word for this lesson is boundary, which divides the coordinate plane into. So it kind of divides it in half. Alright, first example, we need to make sure we remember how to graph before we can start graphing inequalities. So let's remind ourselves how to graph. If I have y equals 1/2 x minus 1, I'll start with the y-intercept, which is -1. I put my dot on the y-axis at -1. And then my slope is 1/2, so I'm going to rise the top number, run the bottom number. Rise 1, run 2, rise 1, run 2, rise 1, run 2. Second one, y equals -3x plus 4. My y-intercept is 4. So I'll put my first dot at 4 on the y-axis. My slope is -3, which is the same as -3/1. So I'll go from my dot, I'll go down 3/1, down 3/1. You can do all of these on the same coordinate plane. Y equals x minus 2. My y-intercept is -2. So I'll put my first dot at -2 on the y-axis. If I have an x and there's nothing in front of it, that means there's a 1 in front of it. So my slope is 1 or 1/1. So rise 1, run 1 from my green dot. And the last one, y equals -x plus 3. My y-intercept is 3, so I'll graph that first. And then my slope is -x, which is -1x. So I'll write that as a fraction, -1/1. So rise -1, run 1, rise -1, run 1, rise -1, run 1. So now you should have 4 lines on your coordinate grid. And again, that is review. That's not the new stuff. All right. If we change the equal sign to an inequality symbol, how does it affect our graph? So that's going to be a big part of the lesson today, is we don't have equal signs when we graph like we did on the last 4 examples. We have inequality symbols. Now just like less than and greater than, when we graph it on a number line, we have an open circle. When we graph it on a coordinate grid, we're going to make our line dashed. So rather than a solid line, we're going to have a dashed line. That's just like an open circle on a number line. Less than and equal to or greater than or equal to are going to have a solid line, just like we normally would have done with an equal sign. We're also going to need to do some shading. Whenever we have shading for less than, we're going to shade down. Whenever I shade for greater than, I'm going to shade up. And that'll make sense in a second. Okay, here's our first example. Graph y is greater than x minus 2. So first let's just graph this like normal. My y-intercept is -2. So put your first dot at -2. My slope, the number I can put in front of an x, is 1 or 1/1. I'm going to make my dots, but don't connect the dots yet. So if we look back a screen, we have a greater than symbol. Greater than, if you look for it, it's right here. Greater than is a dashed line. So instead of making a solid line to connect my dots, I'm going to make a dashed line. And I'll show you what the dashed line means in a second. Then since y is greater than, that's going to tell me which way to shade. That is the other new part of this lesson. I always put my pen on my y-intercept, so right here where I'm making a green dot. If y is greater than my line, if you think about a number line, numbers are getting bigger as you go up They're getting smaller as you go down. Think about a number line. If y is greater than, I need the bigger numbers, so that means I'm going to shade above my line. Now here's what this means. I'm going to pick 3 coordinate points. My first coordinate point is going to be one that's in my green shaded area. So let's do 1, 1. Then I'm going to pick a coordinate point that was on my dashed line. So let's do 2, 0. And then I'm going to pick a coordinate point that is not in the shaded area. So in this area, let's do 4, 0. We're going to see what happens when I plug all these coordinate points in. So the first one was 1, 1. If I plug 1 in for x and y, it'd be 1 is greater than 1 minus 2. So then 1 is greater than 1 minus 2 is negative 1. Is 1 greater than negative 1? Yes, it is. That's correct. If I go to the next one and I take 2, 0, I'm going to plug 0 in for y, 2 in for x. Is 0 greater than 0? No, it's equal to 0. So that one didn't work. So the one in the green area that I picked did work. The one on my dashed line did not work. Now let's see if the one in my non-shaded area, the x, works. So I'll plug 0 in for y, 4 in for x. Is 0 greater than 2? No, it is not. So here's how this works. Every single coordinate point that's shaded is a solution to this inequality. Every coordinate point on a dashed line is not a solution, and every point in the non-shaded area is not a solution. So that's where your answers are up here. All of these coordinate points are solutions. There's hundreds of solutions that would work, but they have to be in that shaded region. All right. Put my first dot at positive 3. Then I'll rise negative 2, run 5, rise negative 2, run 5. Now this one is less than, so I need a dashed line again. Then I'm going to put my pen on my y-intercept. This one says less than, so if I put my pen on the y-intercept, I made a black dot. Less than, remember the numbers up top are getting bigger, the numbers down below are getting smaller, they're becoming negatives. If y is less than, smaller numbers fall below my line. And I'll show you again if we pick a coordinate point. Let's choose maybe negative 2, 0. If I plug negative 2, 0 in my inequality, that should end up being true. So if I did that math, it should end up being true. Any coordinate points on my blue dashed line would not work. Any coordinates in the non-shaded area above would also not work. All right, now we have an inequality that's in standard form. So we have to get it in slope-intercept form before we can graph it, which means I have to get y by itself. So this is a hard problem. So to get rid of the 4x, we have to subtract it on both sides. And remember, you can't combine negative 1 and 4x. You have to leave them separate. I always write the x first. So here is our inequality. So my y-intercept is negative 1. And then I'm going to rise negative 4, run 1. Rise negative 4, run 1. This one is greater than or equal to, so that means I need a solid line. I'll put my pen on my y-intercept. Greater than means I would shade above. So go to your y-intercept and shade above. And it'll kind of seem like you're shading below once you get down here, but that's all considered above our line. Above, greater than is above or up, less than is below or down. So everything that's shaded in the green area would be a solution. Now notice if I take a coordinate point from my line this time, because I have a solid line. So let's pick 0, negative 1. If I take 0, negative 1 and plug it in, I'd have negative 1 is greater than or equal to negative 4 times 0 minus 1. Negative 1 is greater than or equal to negative 1. Is negative 1 greater than or equal to negative 1? Yes, it's equal to it. So with a solid line, those coordinate points are included in your solution. So your solutions are everything in the green and that red line. All the coordinate points in the green and the coordinate points on that red line. All right, to get them, this equation is not in slope-intercept form, so we need to get it in that form. So minus 2x on both sides. Bring down the 3y. This one is a heart because we have to get y by itself, so we have to divide by 3. So negative 2 over 3 does not divide nicely, so leave that as a fraction. Negative 6 over 3 is negative 2. So put your first dot at negative 2 on the y-axis. Rise negative 2, run 3. Rise negative 2, run 3. This one needs a solid line. And if y is less than or equal to, if I go to my y-intercept, less than means shade down. So everything in the red that's shaded and all the dots on my blue line, because it's solid, are solutions to this inequality. Summary. The homework for this lesson is page 318, numbers 12 through 20.